Welcome, you all. Hill, how are you doing?
Doing great. How's it going, everybody?
We're doing in a truck.
Who's that you have with you, Hill?
Pierce, let's come down a little bit so you can get on the screen. So Pierce is here. Say hi, Pierce.
Hi, I'm my name is Bob Panther, not Pierce.
Today, Pierce is Black Panther. He is not Pierce. So that's what today is.
So we're not even
Black
calling
Panther
him Pierce.
is gonna
We're just
learn
calling him
code
Black
today.
Panther.
No, I'm not, because I know how to code.
So Black Panther knows how to code. So that's good.
All right, we're now up to 500 people in the audience. This is pretty amazing to watch. There's about 20 people joining almost every second. So we're now at 550 people in the audience.
Okay, anybody that's joining, tell other people to come on. This is gonna be the largest live interactive classroom happening, and we're gonna learn to code together. Bring your kids, bring the family, gather around, let other people know this is happening and it's live. So
We now have 600 people in the audience, and I'm just gonna get started while people are joining. So welcome to Code Break. There's a few dozen of us on screen, but there's hundreds of more tuning in and about 20 or 30 joining every second. This is our first time doing something this. We're gonna find ways for everybody to interact together. If you've ever joined Zoom meetings and you're looking at this one, you don't have all of the same tools because there's too many of us to talk at all the same time. Together, we're hoping to build the world's largest live interactive classroom. If you enjoy it, please invite others to join. I'm gonna invite my daughter, Sofia, to join in.
Hi,
Hi, Sophia.
Yeah.
I'm Sophia. I'm 11 years old and I'm in 5th grade. Let's go 5th grade.
That's awesome. Hey, Pierce, what grade are you in?
K.
He's a pre-K.
Yeah, I love pre-K.
So Sophia's also got a soundboard. She's gonna make sound effects for our show. So Sophia, what sound effect do you wanna do right now? All right.
Charge.
Today, our special guest is actor and author Hill Harper, who's on screen right now. Obviously, for those of you who are still tuning in, welcome. So Hill, how are you doing right now? How are you handling this whole quarantine situation?
Hey, everybody. You know, being quarantined or doing self-quarantine it's been interesting for sure. One thing that's done is that Pierce and I get to spend a lot more time together, which is I think great. And at the same time, though, you know, I just feel for all those people out there and all those folks who are actually suffering with health consequences, and just reminding everybody that, you know, staying at home, doing this, you don't see the benefits immediately. It's kind of like, I guess, learning to code in a way, right? We do this now to reap the benefits for weeks from now, months from now, and we save lives. So if we can do this together, for instance, build community online through things like this, hopefully we can establish some measure of learning and normalcy, but at the same time, reinforce that if a virus can spread, so can love, and so can support, and so can learning in the same exact way. And so we can represent that here. So I'm so excited that so many people are on. Great, excited to have my son here with me, and Sophia, great to see you, and Hadi, thanks for organizing this.
Of course. We had a corny joke for you, Hill, to get things started. Where do all the cool mice live?
Where do all the cool mice live? Pierce, where do all the cool mice live?
Sophia, you want to give the answer?
Mice?
Yes.
In the hole.
Pad.
In their mouse pad.
In their mouse pad. I like it.
Sorry, I put Sophia up to it. But let's switch to gallery view so we can see all the students who are joining us right now live. So you can see all the faces on screen, everybody.
Hi, students.
Hello.
Hey, everybody.
I'm going to take you all off of mute so everybody can...
Hello.
Hi.
Hey.
Hi.
10:13?
Hi.
No,
You
wait.
guys.
No, wait.
Hi.
No, wait. Is it 10:13? That's the next day.
We're going to go off of mute, but we're going to say hi to a few people individually. We have started. So first, Anthony and Braden, Anika, Gabby, and Xavier. We're going to unmute all of you right now and to say hi to you specifically. Anthony and Braden.
Hi. Hello. Hi.
Where are you all from?
San Francisco.
San Francisco. Awesome. What grade are you guys in?
Second.
Second. Are you guys related?
Yeah.
Oh, really? What's your relation?
We're twins.
Oh, you're twins? Oh, I would have never guessed that. That's amazing. That's amazing.
I'm a twin. That's pretty funny. How about Anika? Are you there, Anika?
Yeah, hi.
Hi, Anika. What grade
Hey,
are you in?
Anika.
I'm in ninth grade.
What grade?
Ninth grade.
Ninth grade. Wow.
Ninth. Where are you?
I'm in Orion, Illinois.
Ooh, very nice.
What's your
Is it-
favorite subject?
My favorite subject is Spanish.
Oh, español. Sí.
Hablas español. Qué bueno.
¿Cómo está?
Soy muy bueno.
Oh, muy bien. Okay. Good.
Perfecto. How about Gabby and Xavier? Gabby and Xavier, are you there?
Hi.
Hi, Gabby and Xavier. How are you? Where are you all calling from?
Midway, Massachusetts.
Medway, Massachusetts.
Oh, that's
All right,
nice.
so for everybody else who's in the live audience, there's almost 1,000 people already. Click to see if you haven't found it already. There's a button like this called chat, because we want to hear from all of you as well. And when you click this button, look for the blue button that chooses who you're chatting with and choose all panelists and attendees. It's a big blue button. And people are asking, there's over 1,000 people here, but what I want, everybody who's chatting, can you stop for a second and not type for a little bit of seconds so we can then ask a question for everybody to answer? What I want to ask is everybody tell us, what city are you in? So Seattle, Calgary, what are you seeing there, Hill?
Oh, I see Columbus, Las Vegas, Vienna. Wow, it's going so fast. Chicago. Oh, Houston. Oh, Bellevue. I can't read that.
Stanford, Washington, Springfield, Memphis, St. Louis.
Chattanooga.
Austin.
Too fast.
Amazing how many people there are. All right, so everybody stop typing that.
Kansas City.
Now I want to ask for the folks who are there, what grades are you in? For the students who are there.
I saw
wow,
Pakistan.
Pakistan. 7th grade, 6th grade.
7th, 6th, 4th, 6th, 44th grade. That's a big one. 5th, Dubai. You're what? Grade 5. 9th, 10th, 5th, 1st, 3rd, 4th, 5th, 3rd, 2nd, kindergarten.
There's so many. All right, we have one last question. We want to get a sense of people's coding capability or computer science capability. So everywhere in the chat window, if you're a beginner, type a 1. If you're intermediate, type a 2. And if you're relatively advanced as a coder, type a 3. We want to get a sense of how many people here have experience with any type of computer programming and computer science.
2, 1, 1, 2, 1, 1, 1, 1. A lot of 1s, a lot of 2s, a lot of, there's a 22, very advanced. 1 and 2.
I saw an 11 there. Wow, I saw a 1,000. We have a 1,000.
Yeah, so there's a 3. There's a 3 out. There's a 2.5. Wow. Okay. So there's some advanced coders in here. There's also a lot of beginners like me, like Pierce. Pierce and I are beginners. We are -1. We're
-1. All right. So for those of you who are calling in from a mobile device, whether on a tablet or a phone, close the chat now. We're going to let you know when to open up again. So we want you all to be able to see the whole screen. For those of you who are older or more experienced, please stick with us through the end. Even if you said that you were a 3-level coder, we're always going to start with easier material, but we're also then going to get more advanced too. By the end of today's code break, you should be able to make pretty cool stuff with only a few lines of code. Let me give you an example of what we're going to learn to do by the end of today with just 5 lines of code. I'm going to share my screen to show you what we're going to make. So if you see my screen right now, this shows you what we'll be able to create. All of the drawings here we'll be able to do with only 5 lines of code. What do you think, Sofia? Sophia is going to do our sound effects. She's my daughter here joining us.
That's impressive. That is very impressive.
Sophia is our lead coder. Now let's talk a little bit about Code Break. Each week we're going to host weekly episodes with special guests. Like today we have actor and author Hill Harper, and we're so lucky to have you on board. We're going to cover computer science concepts in a fun and collaborative way. And then at the end, we're going to send challenge questions for folks to do at home. So if you haven't signed up already to get the challenge questions, you can give us your email address at code.org/break, or if you just Google code break, you'll find it. We're not going to send any kind of spam marketing messages, just the challenge questions from each week's episode. And if you have any questions during today's show, you can ask us these questions. There's a button for Q&A. If it's a question about what you're seeing, or really any kind of computer science question, feel free to ask it at any time, and then we're going to take a break a few times during the hour to see people's answers. The last thing I want to say before we start is this is our first time doing this. Nobody that I know has ever run an interactive classroom at the scale of 1,000 people before, and certainly we haven't. We're figuring it out as we go, and so please bear with us. If things break, we're going to learn a very important computer science concept called debugging. Sophia, you have the drawing you made for this? This is a bug. Sophia drew this bug. A bug in computer science is when something breaks and you need to figure out how to fix it. So if anything breaks, Sophia's going to hold up this bug and we'll fix it. If my screen goes out,
always a solution. There's always a fix.
There's always a fix. In some classes, there's a right and wrong answer, and if you get it wrong, you're just wrong. In computer programming, if you get it wrong, you can tweak it and improve it and see if you can debug it. And so we're probably going to be doing that a couple of times today. So today, the concept we're going to learn about is algorithms. It's a computer science concept we're going to learn, but we're going to learn this with a little bit of fun. We're going to have 3 stages in today's code break. Segment 1 is going to be learning unplugged algorithms. Segment 2, we're going to do some live coding at a beginner level. And then segment 3, we're going to do some intermediate coding as we go along. Are you all ready to get started?
Yes, I am. Let's go.
Sophia's sound effect. Ooh.
Yeah.
All right. So we're going to learn about algorithms. And
algorithm, that's my favorite thing, Hadi. Algorithms. I feel like I'm an algorithmic expert all the time.
Awesome. So an algorithm is a list of steps you give to a computer for what you want it to do. And we're going to do this by having our participants give instructions to give an algorithm to code Hill to make a peanut butter and jelly sandwich. So if I want to see all the students who joined us on screen, we told you in advance to write down your instructions for how to make a PB&J sandwich. So if you have those, can you hold up the instructions you wrote down on paper so we can see them all? All right, so I'm going to call out to somebody.
So Hadi, right before you start, I want to ask everybody a question first.
Okay.
A lot of people, there was controversy about peanut butter versus almond butter. So I got both. I want to see what people want. Do they want me to make an almond butter sandwich with organic almond butter, or do they want me to make a peanut butter? Almond butter and jelly or peanut butter and jelly?
Raise hand to do that.
Which one?
So to do this, you have a button for raise hand at the bottom of the screen. Raise your hand, click this button if you want peanut butter.
Click it if you want it to be peanut butter.
Raise your hand.
Raise your hand.
All right, I see 457, 470,
490, 500. Let's say 500 raised hands.
I think peanut butter is going to be winning here.
Well, you never know. Almond butter could make a big comeback.
No, there's no way. More than half of them want peanut butter.
No, but they may vote again. Raise your hand if you want almond butter.
Lower your hands. Everybody lower your hands, and we can lower your hands for you automatically to get it down.
Okay, peanut butter 1. You're right.
Yeah, peanut butter 1.
Peanut butter 1.
Peanut butter 1. All right, so now Sylvia and Mark and Nia, are you all ready? We're going to unmute you so we can hear from you. Sylvia and Mark. And Nia? Can somebody unmute Sylvia and Mark and Nia? I'm not sure whether you need to unmute on your end so we can hear you. We're having trouble unmuting Sylvia and Mark. All right, Nia, are you ready? Can somebody unmute Nia so we can get our first panelists, our first students to give instructions? All right, there we are, Sylvia and Mark, thank you. And first, I should say that was our first bug. So, Nia, we're gonna hear from you right now. Nia, we wanna hear your instructions for Make a PB&J sandwich, but first, can you say hi to us?
I can't hear. Can you guys hear?
We might have broken Zoom, I'm not even sure. Nia, can you say hello? Let's go back to Sylvia.
I can hear the twins, I think.
Sylvia and Mark, can we hear from you? All right, so let me switch to somebody else. We're gonna switch to Darius and Muzzy. Darius and Muzzy, are you there?
Yes, can you guys hear us?
Hi. Hi.
Hi, Darius and Muzzy. All right, so Muzzy, we want you to give Hill directions for how to make a peanut butter and jelly sandwich. So think in your mind, how do you make peanut butter and jelly sandwich? Hill's got his peanut butter, he's got bread and jelly, and then give him the instructions. But what's really important is you can't change the instructions after Hill started doing stuff. You just need to tell him what to do.
Tell me
All right?
what to do.
Muzzy, are you ready?
No.
Have Darius do it.
All right, Darius, you could do it. Go ahead.
Pick up a slice of bread and lay it flat on the table.
Pick up a slice of bread and lay it flat on the table. You really gonna have me make a peanut butter sandwich on my table? Is that clean? Is that clean? But I'm gonna do it. Go ahead. Yep, go.
Pick up a jar of jelly.
Okay.
And untwist the lid to open it.
Untwisting the lid to open.
Pick up your knife using the handle.
Hello?
Use the handle.
I don't have any hands left. How do I pick up the knife?
Put down the jar of jelly. Using the sharp side of the knife, scoop out some jelly and put it on the bread.
Okay. Is this enough?
Do more.
Do more? How much?
Just do a lot until you think it's enough.
Okay, I'm gonna do a lot.
Good job. That should be enough.
No.
Okay.
Hill, can you
Look.
bend down your camera?
Look.
Oh.
Oh no, you said do a lot.
That's good. So
That's
now,
good.
that's good. Now pick up your container of peanut butter.
Okay.
Look at yours.
Open the peanut butter and do the exact same thing with the peanut butter that you did with the jelly.
Okay.
Open it and just put a lot on the bread.
Okay. It's not coming out the same way. What do I do?
Scoop it out using the knife.
Okay.
Good job. Now okay, stop. Now pick up another slice of bread and put it on top of all of that stuff.
How do I pick it up?
Put down everything you're holding, just drop it. Pick up another.
I think I broke my table.
What?
I think I broke my table.
That's okay. That's not what we're worrying about right now. Pick up another slice of bread. Put it on top of your mound of jelly and peanut butter. Good job. There you go.
All right. Can we all give Hill a round of applause for making a peanut butter and jelly sandwich?
Oh no.
That
I'm
looks
gonna
like it's
try
got
it,
a
though.
lot. It's a pretty big sandwich.
Hey, Chris, you want to try a sandwich?
So what we just saw, we all know that when you're talking to a regular person, they follow instructions way better than Hill just did. Hill acted the way a computer would. When you're giving instructions to a computer, you have to be very precise. A computer may seem smart, but it's actually not smart at all. No offense, Hill, we know that you were acting. A computer needs to hear instructions in the language it expects, and it will make mistakes if you tell it to. It'll eat as much peanut butter as you tell it to. It doesn't know what you want it to do. It only knows what you tell it to do. Remember the word of the day? Algorithm. An algorithm is a list of steps you give a computer to finish a task. It's like a recipe or driving directions. And just now we made an algorithm for making a peanut butter and jelly sandwich. Now we're going to switch to doing some algorithm coding on a computer next. But first I want to take a quick break for a trivia question. It's trivia time. Sofia's got a trivia time sound. So are you all ready for a trivia question? Remember the raise hand button we had? I want you all to lower your hands. So the folks in the control room, can you lower everybody's hands? So the trivia question for today's day is to ask, was the first computer programmer a man or a woman? Was the first computer programmer a man or a woman? Raise your hand if you think the first computer programmer was a man. All right, how many hands do you see there? Hill, how many hands do you see raised? I see 199 hands raised, 200 hands raised, 208 hands raised.
200.
Sounds like either people think it's a woman or they just don't know. 230 people think it's a man. All right, 240. All right, now everybody lower your hands. Lower your hands. And the next question we want to ask is, raise your hand if you think the first computer programmer was a man. Sorry, it was a woman. If you think the first computer programmer was a woman,
I do.
click the raise hand button. So,
Sophia, what do you think?
Computer programmer was a woman, raise hand. Wow, there's a lot more people raising their hand thinking it's a woman. So, Hill, what do you think is the right answer?
Oh, I think it's definitely a woman. There's no doubt about it. I saw the movie Hidden Figures with my friend Taraji P. Henson. So I know it was a woman.
That's right.
I'm not saying it was Kathleen Johnson, but you know what I'm saying.
So I'm sharing my screen right now. Do you all see my screen share? Wow, my computer's going nuts with everybody's hands raised. Can somebody lower the hands? So the first computer programmer was a woman named Ada Lovelace.
Ada Lovelace. I knew that. I knew it.
I knew it. All right, well, Ada Lovelace is the first known computer programmer. And what's really interesting about Ada Lovelace is not only that she was the first computer programmer, but that she wrote the first computer program in 1842, almost 100 years before the first computer was even invented or built. So before we had any kind of computers to do the stuff we do or smartphones, 100 years earlier, Ada Lovelace wrote the first computer program. And the reason this is interesting is because Ada Lovelace did something very similar to what we did with our unplugged algorithm, which we wrote for a peanut butter and jelly sandwich. She was writing a computer program on paper. So now we're gonna go do some real coding to make a computer program. So I'm gonna go back to my screen share and Sophia is gonna do the coding for us. Sophia, are you ready?
Yes.
All right, so I'm gonna go share my screen again. Sophia here is a practice coder, but this is her first time doing something like this in front of such a large audience. Can you all see my screen again?
Yes.
You can see the screen? Great. Sophia, I'm going to explain the screen and what we see right here. On the left side of the screen, what you see is an artist. He's a little guy with a big pencil and he's going to draw whatever we tell him to do. In the middle of the screen, you see the blocks for what the artist can do. Those are his commands. And then on the right side of the screen is where Sofia is going to make the code. Now, Sofia, drag out one block to see what is going to happen. All right, so Hill, what do you think is going to happen when we drag out this one block?
It's gonna, the artist is gonna move straight across and draw something that's 100 pixels long. Gonna move forward for 100 pixels.
All right, it sounds like you may have some prep for doing this. So the artist is gonna move forward 100 pixels. Are we right? Sofia, are you gonna hit the, oh, you wanna make a sound effect? That's right. All right, so we drew 100 pixels. And what's important about the artist is anytime he moves, he's drawing. If you want him to move without drawing, you can use this jump command. Now, the next thing I want to do is Sofia is going to draw something with some instructions. I'm going to whisper in her ear and tell her what she's going to draw. And I want everybody in the audience to take out a piece of paper and a pencil and follow along as Sofia's writing commands for the computer and draw what you think the computer is going to make. And then we'll see if you got it right. So Sofia, everybody follow along at home with a piece of paper and pencil and see if you can follow what Sofia is doing. And maybe you can draw the same shape as her, and then we're going to see if you got it right. Sofia, you need to reset. Sorry.
Oh.
Go ahead.
90 degrees.
Move forward, turn right.
Move forward 100 pixels. Turn right by 90 degrees. Move forward 100 pixels. Turn right. Move forward 100 degrees. And turn right one last time.
All right. So has everybody at home made their own guess as to what is going to happen? I want to switch to see everybody. We're going to stop the screen share. And I want everybody who's on camera, if you've drawn what you think is going to happen, hold your drawing in front of the camera so we can see it. Those of you who aren't on camera, can you type your guess into the chat box? If you remember, the chat box is the little sort of the thing that looks, I don't know if you can see my camera or not, but it looks like this. Click that and type your guess into the chat box. Hill, what are you seeing on screen or in the chat? What are people guessing?
I'm seeing square, 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 box, 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 square, 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 box, 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 square, 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 box, 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 square, 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 box, box, box.
So Sophia, are you ready to share what happens? You want to do a drum roll sound before we see the answer? Let the drum roll.
Oh yeah. Oh yeah. Oh yeah.
All right, we have a square. Now, again, this is very beginner stuff. Any of you who've done coding before have known how to do this, but we're gonna now get much faster quickly and do more interesting stuff. So the first thing we wanna do is to make our square a different color. Sophia, can you choose a color for the square? Can you make it just be a random color? All right, now the square is gonna set color to random, so when you run it, it's gonna be a different color each time. Can you run it? And let's make it a little bit faster so it goes more quickly. And I'll draw another square. What color is that?
Pink.
Okay, draw another square.
Pink.
Another square.
Purple.
All right, so we're getting lots of different colors, but I'd love to see lots of these colors happen all at the same time so you can see multiple squares. So I want to ask some of the folks who are on camera to tell us how we can do that. So can we unmute Jack Barry? And we want to hear from you to see what your ideas are in terms of how we can get more squares on the screen, because we want to have multiple squares of different colors. Jack, are you there?
Yep.
Hi, Jack. So how would you suggest for us to get multiple squares instead of having her to run and then stop and run and stop all over again?
Multiple artists, I guess.
Multiple artists? No, we want one artist to do multiple squares.
Forever loop on a rotation.
A loop on a rotation. And is Barry there by any chance? Or is Barry your last name?
No, that's where I'm.
Oh, you're from Barry. Oh, okay. So multiple loops on a rotation. So looking at the blocks that you see on the screen, can you figure out a block that we can use for doing that?
The pink repeat question mark times.
All right, let's drag that out. So that block can repeat anything you put inside it as many times. So how many times should we have this happen? Can folks in the chat window say how many times do we want to repeat and see a square?
4. There's one person said 4.
4, 5.
I want more. 100. There's somebody said 100.
Somebody said 100. Sophia, you want to type 100 in here?
Put 100 in. And just make it go real fast. So I want to
All
see
right,
it
100
fast,
squares.
and I want to see 100. Fast and 100. Super fast.
Super fast. All right, hit run, Soph.
Ooh.
All right, let's stop this. So that's 100 squares going by super fast. But Jack, if you're still on there, those squares are all on top of each other. Can you think of ideas how we can see those squares, but see them all separate from each other?
Yeah.
Either when they're done, maybe set a script to turn them or move them somewhere else.
Sophia, which of those do you want to do?
Let's turn.
Okay, do a turn. So after each square, we're going to turn the artist a little bit. Why don't you turn him like 3 degrees? And change the number up here to 120. So
No, it's longer.
all right. Now hit run. Is everybody ready to see what's going to happen? Drum roll.
Oh, yeah. Oh, yeah.
I see in the chat room somebody wants us to do like a trillion squares. And one thing I wanted to say for whoever typed that, Alex T and Harley Hendrickson, who wanted a trillion squares. One of the amazing things about computer programming is you can tell a computer to repeat something as many times as you want, and it doesn't get tired. It doesn't say, oh, I want to go to bed. The computer will repeat an algorithm over and over, and it'll not make mistakes. It'll do exactly what you tell it to do. Now, you may make mistakes in what you tell it, but after you tell it what you want to do and then you ask it to repeat it, it will do it over and over. So we could have done 100 times or 1,000 times. I think if we hit 1,000,000 times, I think that might have broken our computer because our computer here isn't.
Good job, Jack. Good job. Excellent.
Thank you so much, Zach. So I want to do something else now. Let's make this drawing a little bit more interesting. We're going to add a cool little sticker to it. Sophia, can you drag out the sticker block? It's down at the bottom of the screen.
Draw us.
Now I want to add the sticker right after the first move forward block. So the first move block is when we begin the square. So what are our options for what we can put in the sticker?
Wow.
Wow, there's a lot of stickers there. I'm also seeing a lot of people raising their hands. If you raise your hand, if you have questions, type them into the Q&A area. But now I want people to tell us what sticker should we use. You see all these options for stickers on the screen? Type in your sticker choices and we can choose from them. And Hill, tell me what you see there.
Pirate, ghost, penguin, wizard, ninja. I've seen a few penguins. I think penguin. A lot of penguins. A lot of penguins. Let's go penguin.
That's way too many choices. Let's actually do something different. I want to have us take a simpler vote. So I want us to choose between 4 options, and we're going to choose the top 4 options. You wanted a penguin, Hill?
Well, I was just being the voice of the people. You
All
know.
right, the voice of the people you think is a penguin. What do you want as your favorite option?
Oh, my favorite option. I like this little guy down here, bottom left. I don't even know what you call him, but he's got the big eyes and he's hanging out
Little
down there.
guy down here. All right, Sophia, what do you want?
Let's do the chicken.
Where's the chicken?
I don't know.
Can you point to the chicken?
That one.
There's the chicken.
Yeah.
What's this little guy's name? Number 2. What is his name?
I'm going to choose a little alien. Oh, no, it's not an alien. It's a zombie. All right. So now in the chat room, type the number for who you want.
Number 2, you guys.
Penguin.
Number 2. Number 2. Go 2. Big 2. Big 2.
All right, Hill. It sounds like everybody wants your choice. So we're going to go with number 2 here. And we're going to close our little voting area. Sophia, you want to choose the little guy?
The little guy with the big eyes.
He's over there. Little guy with the big eyes. And now for the turns here, can we make each of these turns 33 degrees apart so people can see these stickers a little bit apart? All right, now hit run.
Oh, yeah.
So every time we draw a square, we're adding a sticker, and it's doing it over and over again. 120 times, so that little guy is getting repeated many, many times. And so it's basically adding to our picture here. Now, one thing you notice is I changed the angle as we're going along. One of the best things about computer programming and computer science is, unlike a lot of subjects you learn in school, it's not just about getting it right or getting it wrong. What we're doing here is just we're being creative and we're playing around. So there's not really a right or wrong answer. Just like in art class, your art teacher doesn't usually tell you, oh, that picture was wrong or you got it right. You're just making something pretty that you can then share. And when you're done making it, you can click the finish button and you can see what you made. You have a URL to it that you can send. You can send it to your mom or dad's phone. Or if you have a social media account, if you are a mom and dad, you can post it to social media. Or if you want to change it and you want to keep going, you can click keep playing and mess around with it some more.
That's going to be my new profile shot on my Instagram. It's going to be
all right.
People are going to love it.
So I'm going to stop the screen share for a second, and I want to see if we have any questions from the folks who've been in the audience. We might not, but I want to give a chance if folks have had any questions from what they've seen before. And these could be questions about what you just...
There's a lot of raised hands. There's a lot of raised hands.
We did have one question. It was specifically for Hill. Was the peanut butter and jelly sandwich delicious? What type of jelly was it? Where did you get it?
Oh, okay. Well, I will answer that. It was organic wild Maine blueberry jam. So this is from Maine.
The fancy stuff.
Great state from Stonewall Kitchen. And then the peanut butter was this organic peanut butter from Trader Joe's, which is good. Now the bread was this some kind of organic Steelers bread, whatever. I think that the directions overdid the jam. It's too sweet. It's too much jam in a jam to peanut butter ratio. I'm eating it anyway because I'm really hungry, but it's the jam to peanut ratio is not programmed properly, and that's no knock against the programmer. I know that it was their first time programming a peanut butter and jelly sandwich or coding one. So I think the next time we code this, like Hadi said, there's no right or wrong, that we should code less jam and more peanut butter and maybe even less bread, to be honest. I could do for just like one slice folded over or something like that, but that's just me. That's just me personally.
All right. There's a question from Christine Hawley asking about the artist, saying, is forward relative to where you are? Because when Sofia said, move forward, turn right, move forward, turn right, I thought it was going to be stairs because I thought forward always meant right. And so, Christine, forward depends on which direction the artist is facing. If the artist is facing right, move forward takes it to the right side of the screen. When the artist turns right, then it turns relative to where it was already pointed, and then it points down, and then it moves forward to go down. And then if it turns right again, it'll actually be facing left. So, and each time it moves, it goes in a direction, and each time it turns, it changes that direction. All right. So,
that's a good question. So just so I know, would you do steps? Since she thought that was steps, how would you do steps?
Do you want to take a guess at that, Hill?
I absolutely do not.
Okay.
I assume you go move forward left, then go move forward right, move forward left, move forward right.
Exactly. Move forward, turn left, which is actually going to then point you up and then go up. In fact, let's go do that right now, and I'll show you how that would work. If I take these squares, and I'm just going to take...
Go back to your screen so we can see you coding.
Yeah, sorry, thank you. And we're a little bit off script, but I want to do this because somebody asked a question about it, and it'd be helpful to see the difference, and then we're going to get into advanced coding afterwards. So here we are. And what I'm going to do is I'm going to reset this little thing we had with the sticker, and I'm going to get rid of the sticker for now, but we'll bring it back in a second. We're going to move forward 100, and then you said to turn left, then move forward and turn right, and then move forward and turn left, then move forward and turn right. And if we do that, it'll draw stairs. And I can make it so that each one of these stairs is 10 steps long. And in fact, after I just do 2 stairs like this, move forward, turn left, I can then repeat that 120 times. And it's drawing stairs of different colors.
Wow.
Wow, you sound super excited, Sophia. So Christine, thank you so much for that wonderful question. I'm not sure if you were hoping to get that much attention to your question, but thank you, Christine. And we hope you try coding yourself. And after the show, we're going to send the links so you can practice with this. But what I want to do next is to show more advanced coding. And if you remember, and you can see on my screen, we're now in section 3 of showing more intermediate level coding. Sophia, are you ready for this part?
Yeah.
So I'm going to be doing the coding on this part now, and Sophia is going to be making sound effects and making fun of me as we go along. We're now in a slightly more advanced version of the same tool. So this is a more advanced version of Artist. You have the same blocks, but they're not all laid out here. They're in different sections. So there's action blocks like move forward or turn right or jump forward. There's brush blocks. And one of them, for example, sets the width of the brush. I'm going to set the width of the brush to 1. So it's like draws a thin line so we can draw more fine-tuned stuff. But you can see we have loops like the repeat block and these other things like logic for if-then statements or functions and variables. And these are other computer science concepts that we're going to learn over time. So the first thing I want to do is show how we can just draw a simple square like we did before. I'm going to draw a repeat block. And again, this is going to be relatively simple, but then we're going to get a little bit more advanced. So I'm going to say, let's move forward, let's say 50 pixels, and then turn right, 90 degrees. And a square, if we move forward, turn right, and repeat it over and over 4 times, this should draw a square. It's a fewer lines of code to draw a square. How exciting was that, Soph? All right, Sophia's falling asleep. Now we can try drawing different square shapes by drawing angles. So let's draw, let's say, a triangle that's got 3 sides. So I'm going to repeat 3 times. What's the angle we should do for a triangle? This is something that gets confusing sometimes because if you're in math class, you know that the angle of the inside of a triangle, if it looks like this, is 60 degrees. But when we're an artist, the artist is actually turning. So the artist angle is this outside angle of the turn. That's 120 degrees. The inside of the triangle over here is 60 degrees. So if we have a 120 degree turn and we do it 3 times, we get a triangle. And we can now do a hexagon 6 times. And since I've done this before, we can go 60 degrees and this will draw a hexagon. Or we can go, you want to do a pentagon, Sophia? A pentagon is 72 degrees. Now I've memorized these degree numbers, but you can just learn them through experiment. You think I haven't memorized an octagon? I'll figure it out. For an octagon, it's 45 degrees. And we can do 8 times. All right, was that exciting for you, Sophia? Wow, you got excited by that? Sophia has never seen me draw an octagon before. So now I'm gonna change this to say we can do whatever shape we want. So instead of repeating 8 times, I'll say let's repeat 100 times. And so we can change different degrees. So we can make very few degrees, very tight turns, like 160 degree turns. And if we hit reset and run, look what it does. And it just goes over and over on top of itself. Or we can make a slightly weirder number. And now it's going to draw this cool little circle. But now I want to show a different type of repeat loop. Because what we're doing right here is just repeating over and over and over and drawing the same line and then and basically it's the same. And by the way, I want to say for some people that are asking, how is this coding even working? Why is it going with blocks instead of what they expect as coding? Everything we're doing here is actually under the hood is JavaScript. So if you see this right here, this is the JavaScript code that matches the blocks over here. It's literally the same thing, but this is how computer programmers in the real world do it. They write this stuff by typing it instead of dragging and dropping blocks. But it doesn't matter. You can do the same thing with blocks. And when we learn about algorithms, it doesn't matter whether you're typing it or not. It matters which blocks and which commands we use. So what we're going to do now is do this new type of loop. Instead of the repeat loop, we're going to do a for loop. Sophia, have you learned this before? This is your first time too, isn't it? This for loop is a counter, and we said let's repeat. Before we were saying let's repeat 100 times, but we can do the same thing. Let's count from 1 to 100.
1,000.
1,000? I'll say let's count from 1 to 500. Actually, but you can choose how much you want to count by. So let's count by 5s. So I'm going to count from, or shall we count by 3s? We'll count from 3 to 500 going in steps of 3 each. Okay, so it's going to go 3, 6, 9, and so on. And what we're going to do is after each step, it's going to move forward 50 pixels. But if you run this, it's just basically drawing a square. What we can do is, since the counter is changing, it starts at 3 and then it goes at 6. Hill, what do you think we could do to make each one of these steps a different length?
We could change the number of pixels it moves forward.
Right. So instead of going 50 pixels, now what number we can do, if we want it to be different each time, there's a variable called counter that matches what's happening in the repeat loop.
Have it add 10 pixels every time it goes.
So it's the first time it's going to be going 3 pixels, the next time 6.
Oh, I see.
Because we start at 3 and it's going to go to 500.
Gotcha.
And we'll run this in really slow motion so you see what it does. It goes forward 3, turns, goes forward 6, turns, goes forward 9, then 12, then 15, then 18, then 21, then 24. Do you want to make it faster, Sophia? All right, we're going to go faster. The nice thing is computers can go super fast. Sophia, is that good for you?
Yeah.
All right. So look how few lines of code it took to do this. Just counting, move forward, turning right. And now what's great about this is if you experiment with this here, we can do lots of interesting things. So now I can do 120 degrees like what makes a triangle. And I run the same thing and it makes a triangle-like shape.
Octagon?
You want to do an octagon? We can do the, oops. We haven't done an octagon before, except a little bit earlier. If you do the same thing with an octagon, it makes an octagon-like shape. Now I want to show something else we can do. We can go into brushes and choose a different pattern for the brush. There's many patterns we can choose from here. There's 4 or 5. So can folks in the chat room say what pattern we should use? You can see a line, a rainbow, a rope, a squiggly, or what would you call this one here?
It's a chain.
A chain. All right, what are folks asking for?
Rainbow is winning by a landslide.
Rainbow is winning by a total landslide. So let's do a rainbow, and I'm gonna run this. Ready, set, go. All right, that's pretty cool. So I wanna try something different. I'm gonna go back to a regular line, and going back to the way we were doing it as a square. Do you remember when we had this as a square, when it drew like this? What's pretty cool is if you make it just, this is a 90-degree turn, which is what squares have. But what if we made it just a little bit less or more than 90 degrees, so 89 degrees? The turn on these angles will be a little bit tighter than a square. So if you run this, it's gonna spiral. And you actually don't need to be a geometry expert to do this. You just experiment and play with different numbers and see what it does. But if we did this now with a rainbow, check out how it looks. Come on, Sophia, can I get a sound for that? Yay.
That's cool.
We try
you want to try what?
squiggles.
You want to try a squiggle? So
And then rope. Let's do rope.
you want to do a squiggle? So let's try a different angle now. So I'm going to do like this angle and see what happens. And there's a squiggle going around like that.
Rope. Let's do rope.
You want to do rope?
Rope. I see a lot of ropes.
Which is the rope? Oh, that's the rope.
Yeah, that weird candy.
Oh, a lot of people ask for rope.
Yeah.
Right, let's pick a different angle for this. I'm gonna go like that angle.
It does look like real ropes. It really does.
Whoa. So the reason I wanted to show you all this, if you see how many lines of code we have here, 1, 2, 3, 4, 5 lines of code. And in fact, we don't even need to set the width of this brush anymore. So the code that does that in JavaScript is just those lines of code. And if you change the angle and change the pattern, you can get all sorts of different drawings. It's really not that complicated. If you forgot how I did this, this whole live stream of this is going to be on YouTube as well, so you can do it yourself. And now what we want to talk about is how you can go learn at home and try doing this at home to make your own beautiful drawings. And by the way, you don't need to be limited to these 5 lines of code. This is just what I showed today, but there's lots and lots of different commands you can use in this area to make interesting stuff. So let me get off of the screen share for a second now. Hill, you still with us?
I'm here. That was fantastic. I'm excited to go do it myself and create some amazing art through coding.
All right. So what I want to ask for folks to do is when you think about making these art, we're going to give you some, basically some challenges, some take-home questions, or basically some take-home work to try this on your own. Before we go into that, I want to ask, are there any more questions? Akira, have there been any questions that came in on the message line?
We have a couple for you and a couple for Hill. So for you, Hadi, someone asked, I have 2 6-year-old boys and I'm teaching them coding through Code.org, although sometimes their attention strays and they get bored. What advice would you have for somebody learning coding and they may be a bit discouraged?
So my first thought is coding is a lot more fun when you make it creative. And you know, on Code.org, we have some exercises, but we also have some projects. So if you're on Code.org, there's a little create button. And if they're bored, having them go into the create button into the artist, which is takes you into this tool we just showed, let's give them a chance to make what they want rather than doing sort of the more school-like exercises. But I also would say, since they're kids, let them take a break as well. You know, at Code.org, we're very aware that parents don't want their kids in front of screens the whole time. Being in front of a screen coding is wonderful because it's creative and educational. We also have unplugged activities that kids can do to learn computer science, a lot like when we had Hill make a peanut butter and jelly sandwich. And in fact, we're going to send an email at the end of this to tell you about an unplugged activity that kids can do together or with you that teaches the same kind of concepts, but without the screen. And it's a little bit more fun because it's more physical and sort of, you know, in the real world.
Great. And for Hill, how did you first get involved in computer science and what does it look like in your everyday life?
Oh, wow. So it seems like technology is everywhere. You know, I feel like I have to, come with me, I'll show you something. I have this shower, right? And it feels like I have to know how to code. Like I have to know how to code to turn on the shower. So this is like a glimpse into the future, I feel like, because I couldn't even, if I didn't know how to, it's like this shower is so confusing to me, but that's the way we are. We're at a place. But I think Hadi would tell you, Hadi, aren't we at an inflection point where technology and coding is actually going to get more user-friendly, just like using a computer has gotten more user-friendly, like instead of having to learn how to write JavaScript or instead of having to learn how to do, I hate to say this, long division, we can actually use a calculator. Is that going to be the same for coding as time kind of goes by, that we don't have to learn how to do JavaScript, we can just learn how to put things together, and then we could be even more creative because we're not so much spending so much mental energy on learning the actual, it's like you learn how to drive a car, but you don't necessarily have to be a mechanic to drive a car, right?
Absolutely. So first of all, in case anybody is wondering whether the question that was just asked or the view into Hill's shower was planned, that was definitely not planned. I wasn't expecting to see the inside of your shower on our first code break. So thank you, Hill, for walking us into the shower for that sneak peek of the tablet you've got there. But yeah, absolutely. Computer programming, when my father first learned it, involved punching holes into a cardboard piece of paper, and whether there was a hole or not a hole was kind of a 1 or a 0, and you shoved that into a computer, and that was how you did your computer program. And then 10 years later, you had to type numbers on a typewriter, but those numbers were the computer program. And then as time has gone on, you have to learn these sort of more sort of English looking like languages, like the JavaScript language that I showed earlier. And now, as you can see, this dragging and dropping of blocks, you can use the block-based programming to do very, very complicated stuff. And it's getting easier and easier. So what's great about computer science is as it gets easier, more of the sort of busy work goes out of the way, and it's much more about learning how to communicate what it is that you want. And in fact, you know, computer scientists often are very good communicators because they practiced communicating what they want or what they need, but they're also very literal and very explicit, because the more you work on programming a computer, it's like programming Hill was for making a peanut butter and jelly sandwich, and they want to know exactly and very precisely what's needed. But the actual languages are getting easier and easier. I started on C, which wasn't nearly as easy as Python, which is one of the most popular programming languages, which is just easier to type. You're learning Python? Where are you learning Python?
Tech class.
I didn't know that. That's pretty awesome. All right, we're almost out of time. So what I want to talk about is the exercises we want to do before next week. So we're going to send you all an email with exercises you can make. If you aren't signed up for our email list, go to code.org/break. Oops, let me make sure this is in front of the camera. Code.org/break. We're not going to send you marketing messages. You're just going to get an email with the exercises with the links to where we just were playing ourselves, so you can make your own stuff. What you're going to get is, if you're a beginner, you're going to get an exercise that asks you to make this drawing. This is really not that hard to do, and all of you can do it, I am sure. If you're more advanced, Sofia is going to hold up what we want you to do, which is that drawing. This is a lot harder. It's a 10 by 10 grid of squares, so it's 100 little squares. But this is interesting because what you're going to need to do to make that is come up with an algorithm that's different than what we showed you. And as you look at this, you have to ask, well, what's the algorithm for doing this? Maybe you want to draw 10 lines across and 10 lines going up and down. Maybe you want to make a row of squares and then come back and make another row of squares. Maybe you could do sort of a spiral of squares going around in a circle. You can come up with your own algorithm. And you know, we talked about algorithms before. Like I said, there's not a right or wrong way to go about making that square. You could do one of many different ways, and we want to see what way you come up with. After you make your algorithms, what we want to do is to have you make your own creative creation. So here are examples of things you can make with code that Sofia and I made earlier. Sofia, you want to hold your examples up? It is, as you saw, very easy to make cool drawings like this. On Code.org, somebody's posting something of this nature roughly every 2 minutes. So everybody in this group can make your own drawing. And parents, if you're there, we want you to share these drawings to social media. If you share to social media, use the hashtag CodeBreak, so the team at Code.org can reshare what you've created. And we have over 2 million people who follow Code.org on Twitter and Facebook and on Instagram, and they would love to see what your students are making. For those of you who don't have computers at home, we have 2 options. You can do coding on smartphones, and we're going to send options in that email for how your students can download an app to learn how to code. And also, if they don't have a smartphone or you just want to give them less screen time, there's an unplugged activity, as I said earlier, which teaches them how to make algorithms without using a computer. All you need is a bunch of paper cups. And I'm sure that with this coronavirus quarantine, I bet many of you have paper cups. And so you can learn how to make an algorithm without writing any code. So again, if you haven't signed up already, sign up at code.org/break, or just Google CodeBreak, and you'll get to see how that works. So we're now done with the show. I want to say thank you to everybody. Can we get all the audience on camera so we can say goodbye to all of them at once? And can we unmute everybody so everybody can say bye?
Hello.
Bye, everybody.
Bye.
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 You guys
Bye-bye.
are awesome.
Thanks to Hill Harper.
Stay healthy, stay safe.
Bye.
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 Can we end with like a dance party or something? Sophia, you got any music? Let's end with a little dance party. Dance party.
Mozzie, come on.
So before we close, I want to recognize what a unique time we're in, with tens of millions of students at home and the entire human race working together to fight a new virus. None of us have seen anything like this. I know we're all making the best of this. So many groups are using their imaginations to solve old problems in new ways. And that's what we're trying to do here. Thank you for giving me and my team at Code.org to a chance to give you an hour of education and a moment of community in the middle of all our aloneness. And I want to give a special thanks to my friend Hill Harper for being such a great sport and joining us for our first code break. Are you stuck at home and tired of studying? Take a code break, and goodbye, everybody.
Awesome.
Bye.
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 Bye, Hill. Thank you.
That's correct. I am standing up with all my friends in case you
Our
didn't-
dance party.
All right. Bye, everybody.
Ozzy.
Close the meeting and then.
Right, got it. Okay.
Email for the weekly sound.
No, that's not me. That's not anything.
Which one?
Jeremy Bowen. Need to help its inventional. Stop it! Leave meeting.
California kan hayao San Diego 人跑出去，我觉得会3个月。
Ba ba ba, ma ma ma, da da da, na na na, ga ga ga, ha ha ha.
对，他们就是叫10月April 10月1号，我不记得，可是可能